Well, okay. Well, thank you so much, Klaus, for doing this. Really appreciate it. So it's been fantastic to be here. Thank you for taking the time. It's an honor. So
it's a great pleasure to welcome you at the Technical University of Munich and to do this podcast with you.
It's a beautiful university, so it's fantastic to be here. Thank you so much. So I want to start with something like more general, right? Right before we started, we were talking about this. So you spent a lot of time in industry before coming to university. How do you see the role of industry in this whole traffic flow research?
I spent about 7 years in the German car industry. And I got an offer right after I finished my PhD here at TUM. I'm a TUM child. I did my diploma and my PhD here. And after years, I came back as a professor. But first, I left to BMW, which is a very famous German car maker. And the headquarters is here in Munich. And at that time, they had a research department. And the research was about navigation systems, driver assistance systems. Yeah, not as advanced as today, but already fairly advanced. And they had the idea to conduct research also in this area. So I was working on new navigation algorithms together with Mike Bell, by the way. And we developed algorithms for risk-averse routing, so not minimizing travel times or distances, but the risk of being delayed or the risk of being early. Very advanced research, I would say. Unfortunately, it never became part of a product, because that was the basic idea. But out of this, I worked on a methodology, and I still consider this one of my main contributions in research or in general in transportation. But it's not published because it's patented. And I did a patent on an evaluation method of real-time traffic information. So how can you evaluate the quality of a real-time traffic information service provider? And that is really, and actually implemented at TomTom and at other providers, and they pay some money. I still get some money from this patent. Not much, I have to say, but a little bit. That's the direction of industry. So research or patent. And I really enjoyed the time there. I learned a lot. I collaborated a lot. I got into huge projects. They do huge projects there. And I learned even more after that, because I left industry and ran a consultant office after that for 4 years. And there, all my organizational skills, I would say, come from this time, because as a general manager of a consultant office with about 30 engineers, you're in charge of everything, the finance, HR, but also all the customers, all the employees. So that's very different to what I do today.
That's interesting. So you mentioned this. I've always been curious about this. So the whole transition, because you publish a lot these days in archive. You publish data for people to use for free, and clearly, the industry do not have that sort of mindset. So how was that transition for you?
I see a real danger that we as researchers these days do not have access to the real interesting data. The real interesting data are with Google, Apple, and Waymo. These would be really interesting data sources. This is a big dilemma, I have to say, that we do not have access to data of an autonomous vehicle. Of course, we could create our own autonomous vehicle, but imagine just the size of the database that Waymo must have. That would be really interesting. And it was already the same when I was in industry. So we had floating car data, or extended floating car data at that time that no one else had. But on the other hand, industry does not have the manpower and the financial resources sometimes to really have a deep look into their databases. And they are not doing enough analysis with all those data that they have. Fortunately, I had a PhD student funded by BMW, and that was a really successful story because he did the algorithms and methods with me at the university, but could use as an internal PhD and employee of this company also get access to their floating car database.
Interesting. I think that's very unique in Germany. I'm not sure if any other country does that, but I've seen that quite often in Germany between like automotive industry and universities.
Yeah, Germany is an industrial country, and the automotive industry plays a major role in Germany. And since I was working for them, I'm considered a friend of the German car industry, and I think that's unique. But I also have to say that the collaboration was better 5 years ago. So also in this part of industry, you see that the economy decreases, that money is not available than it was a couple of years ago. That's a bit frustrating, I have to say.
Yeah, I have a feeling that rushing into the EV market costed a lot of these companies a lot, but it never kind of like became realized market, at least at a scale that was expected. I don't know, maybe in the US that is still true. I think Tesla is still the only one that really sells electric cars. The other ones are very few cells every quarter.
Yeah, that's true. And I think the problem is there are two major challenges. One is the electrification, so changing from combustion engines to electric vehicles. And especially German car manufacturers were very good with combustion engines. Yeah. They were famous for them, and the diesel technology. And the second challenge is automation. And both cost lots of money. And these companies are big, but they're not so big. So both would mean huge investments into new plants or in new employees, computer scientists, whatever. And I think also from a financial standpoint, this could be a bit too much for small German car manufacturers. It might sound ridiculous to call them small, but when you look at the money that you need for autonomous driving, it might be the case.
Yeah, I mean, they raise in tens of billions and still go nowhere. Right? That's interesting. You guys are doing some very interesting works in that area, by the way, in autonomy. So I was looking into. I saw your presentation last year. That one of your colleagues was presenting, and then I checked your website as well. There's this whole idea of Munich testbed for connected and automated mobility. Mm-hmm. What is that about?
Yeah, we already spoke about the problem that we do not have access to the real interesting data because they are owned by car industry or by mobile phone industry. So we have to produce the data by ourselves, more or less. And the idea of a test bed in Munich or a TUM is that the university invested into a playground, you could say, for us transportation researchers. It's just an area a little bit outside of the city, 2 times a soccer field. That's pretty much the size, and we can construct and build whatever intersection we want to have. The test bed is equipped with all kinds of sensors, LiDAR sensors. You could fly drones there. video cameras. Parts of it has inductive charging. So we can have a look at specific scenarios in traffic that are of interest. And I see especially situations where autonomous vehicles interact with pedestrians and cyclists. So turning movements, right turn, left turn. And on this test bed, we could repeat an experiment because I see a methodological lack in our field. Lots of people do data analysis, they do simulation, but we are not doing experiments. And a test bed gives us the chance to do controlled experiments. So with real people, but we can repeat it. And we can measure it, we can observe all the behavior, and out of that we can improve our simulation models and our algorithms or whatever.
Do you see any value in replicating the Waymo open dataset? Like they have these 10, 20-second trajectory scenarios with all the objects. Would it make sense to replicate those and try to figure out what they are doing? Like reverse engineer what these companies are doing? Or you see more value in more of explanatory research of trying to explore new ways of doing this?
Both could be interesting, I have to say. To create data sets for others could be interesting. And especially since it's a controlled experiment, we could always increase the number of cyclists, the number of pedestrians, and create more chaos. Yeah, we are controlling the whole situation, and that could be very interesting, I think. Because in Europe, when you talk about traffic or urban traffic, you immediately get the question, how can a pedestrian be integrated or cyclists? So in the future, these are the big challenges for autonomous vehicles. Interaction and collaboration with these two modes. And explanatory, of course, we could create new things there. I see the bicycle as a very interesting mode. We have a very, very interesting bicycle with lots of sensors and equipment, because I would almost guarantee that we see much more technology on bicycles in the future. So connected to mobile phones, bicycles as sensors, and then they can interact with traffic signals, with vehicles, and so on.
That's interesting. So when I was looking at your most recent publications, like there are two distinct categories related to this comes to my mind. One is you guys have done a lot on the interaction side and how pedestrians and bicyclists interact. You also looked into sort of using AVs as sensors. Mm-hmm. So, and I'm not sure if there are any plans to even combine them, but I'm quite interested in that AV as sensors. There's some movements like sort of in the US right now to figure out if this is a viable even strategy. I've just been curious to see what you think about it.
Yeah, the AV is, from a technological standpoint, a fantastic automobile. Yeah, it has tons of sensors on board, but at the moment the colleagues only use them for calculating trajectories, more or less. And the idea is to get access to this data and to use those data to detect the traffic state, but also to detect parking, to detect bicycles or pedestrians. And these days we only get GPS points from vehicles. So only the single position or the position of a single vehicle. And we see lots of potential in that. you can measure almost everything with the vehicle because it has so many sensors on board. And the idea is also, because we assume that lots of automated vehicles will be in fleets of on-demand shuttle services, that you could park vehicles that have to pause or that do not have a job on the side of a road and use as a detector, or to send somewhere to detect things. So the trip is then not for a customer, but the trip could be to sense a certain area and get an up-to-date information. And we are doing lots of on-demand mobility research as well. The vision is that such a service provider would not need any outside information. So the vehicles create the information for the real-time traffic states. You have the forecasts as well. And from those, from all this data, you create your whole service. You could even sell the traffic state to a city because you operate a huge fleet of vehicles in a city.
That's interesting.
And multimodal, so you could also detect bicycles and pedestrians in German cities, and I would say in all European cities. We do not have enough sensors for cyclists or bicycles and pedestrians.
I think that's pretty much true for most of the world. Yeah. But this is a very fascinating topic. So this is the first time I'm hearing this in the sense of like using parked vehicles as sensors. I've heard a lot of people talking about using the parked vehicles as a compute power. But as a sensor is interesting. Have you looked into, I'm just thinking out loud now, but have you looked into where that vehicle should be located? Because if you can't move it, you may also move it to some place that matters more. How do you figure that out? Have you thought about it?
That's a PhD topic a student is currently working on, yeah. Because you're going to have blind spots in a city, especially in a scenario where you only have vehicles as sensors, yeah. The demand might be somewhere else, and then to figure out when to send a vehicle and to get an up-to-date information from a part of a road network or from a certain area. But that's currently part of our research to figure out the right strategy for that.
This is very interesting. So this fits right into your work on digital twins, right? Mm-hmm. So that is rare. I've seen a lot of digital twin work in different fields, like electrical engineers do a lot of it. Even in civil engineering, like construction people do it. But I haven't seen much in the transportation traffic flow world. How did you end up working on it?
I have a colleague here that is really interested and also good in digital twins. He's coming from Geodesy, and they built a digital twin for the city of Munich and of the city of Munich. Yeah? And since they do not only want to have the built environment, they also wanted to have dynamic information. They contacted us as traffic experts. And that's how it started, our collaboration with experts on digital twins. And more or less a well-calibrated simulation of a city of Munich, traffic simulation, is a digital twin as well of a city. But we combine that with the built environment. And for us these days, it's very easy to create a sumo network or a micro simulation out of the digital twin directly. And on top of the digital twin, I see again our test site. I call this an experimental twin. So a digital twin, you can do a simulation of an intersection, optimize the traffic signal setting, whatever you want. And having an experimental twin for example, at the test site where you rebuild this specific intersection, could allow you to get even more insights and provide better solutions, because you could create scenarios with pedestrians, cyclists, and vehicles or public transport that you cannot really observe these days in the real world. Imagine a world in 5 to 10 years where we're going to have much more cyclists, elder people, yeah? So more bicycle traffic. You cannot measure this today. But in an experimental twin, you could create a scenario where you just say, okay, I increase the number of cyclists. I have students that do that. And then I measure this situation and look how the intersection operates. Could be really, really interesting.
This is interesting. So I have two things in my mind. You mentioned this. I'll start with the more kind of like focused version of it. So on the cyclist side, I've noticed something interesting. So it used to be like if you are, as you get older, even if bicycle was the main mode for you for transport, as you get older, it was becoming like infeasible at some point. Now we have electric bikes. And so pretty much that aging population that used to bike and now they couldn't 20 years ago, now they can. Have you seen any sort of trends? I'm asking because we don't really have any sort of bicycle system in US, which doesn't exist. So I'm curious to see if you have noticed any changes in the environment.
In Germany, I see a huge heterogeneity in the bicycle fleet and bicycle riders. Yeah, very young people, very old people, electric, cargo bikes, totally different behavior, bikes with a stroller. Then you see people cycling really fast because they do this as a sport. And I think we do not have enough insights there from a scientific point of view. So we need to measure more drone experiments, trajectories, because this heterogeneity could produce lots of problems in the future. Or even more, that we need a different infrastructure, because the bicycles still operate on the infrastructure that we developed many, many years ago, bike path parallel to the road, certain width, and that might be not the best solution in the future when we have a very heterogeneous fleet.
Interesting. So I'm going to go back to the other question because they're related somehow. So you talked about digital twin and the experimental twin and how these two are related. And so here's something I've always thought about it but never found a good answer to. What is the limit where is that limit that distinguishes between a real world experiment and a digital twin? So you can do very abstract thing, obviously, still would be a digital twin concept, but you can increase the fidelity of the simulation. Where is that boundary?
I'm not a big fan of simulations, I have to say, and simulators in general. We have simulators, and I see their potential in safety critical investigations. But for analyzing capacities and efficiency oriented and answering efficiency oriented questions, I would prefer an experiment. So only because of ethical reasons, I would say a simulator makes sense, not for efficiency. I want to see this in reality, or at least in an experiment. So that's how I distinguish between simulations and simulators and real-world experiments. Where we use microsimulations of Munich is when we talk about traffic states and the behavior of an on-demand fleet and things like this. I think on such a level, a simulation produces good results. But on a microscopic perspective, to analyze right turning movements, left turning movements, interaction with pedestrians, and so on, I'm very skeptical.
This is very interesting because I was when I was reading your papers, I was curious to see why you have done so many data-driven research. Well, this answers it. So most of the things you've done is have some data elements, right? Either you collected the data or you found data somewhere. Yeah, it's interesting to me. So one of the things that caught my eye was you have done a lot of work on trajectory prediction for vehicles, pedestrians, bicycles, and also you've done a lot of work on traffic state estimation. But so they're somehow related, right? But how do you distinguish between these two lines of research? Do you see any difference between them, or do you see they're completely connected?
Traffic state estimation is something I'm working on since the beginning, more or less. And we always had the problem that we did not have enough sensors, at least at the beginning. And I think we're going to see a big renaissance of traffic state estimation because the quality of an on-demand service is highly dependent on the quality of the traffic state estimation in a city and the forecast. If we do not estimate the state correctly or forecast the state correctly, then the on-demand service will have a very poor quality. So we will communicate wrong pickup times and travel times more or less the whole time. And then this service gets a problem of acceptance. So that's why traffic state estimation is very, very important and will see a renaissance, in my opinion. Because lots of people left that a bit behind. And these days it's easy because they are all using a microsimulator and they have access to traffic states from the microsimulation. But in a real-world service, you have to create this state from the sensors you have in the network. And as we were talking about before, we think that the vehicles play a major role in providing information. The trajectory came into my research because I think within the trajectory of a vehicle you can find lots of information. And I see a big lack in analyzing trajectories of pedestrians and cyclists because there's a general lack that not too many traffic theorists take care about cyclists and pedestrians. And I think we should put much more attention on how they behave and what they do. And the trajectory is the best measurement we could provide. And we did two big drone experiments in the city of Munich and in Ingolstadt, where we measured everything: pedestrians, buses, vehicles, and everything is open source.
So when you talk about trajectories and trajectory prediction, do you have any sort of plans to connect that to more general network level traffic state estimation? Because it's still going to be unobserved areas. So would that work at all? Or do you have any sort of theories related to it? Care to share?
Not really, I have to say. Because I mainly look at the trajectory in the past of the vehicle. I'm not interested in calculating trajectories for movements or things like this. I leave this to people that do autonomous driving or whatever. Yeah? I see it as a great measure for detecting the past traffic state. Same for pedestrians and cyclists. And I'm not focusing on that in my research.
So I want to get back to one thing that you mentioned and the lack of enough modeling for pedestrians and bicyclists. So generally we have a few very famous models, right, in both of them, and they're mostly physics-based. There is a whole bunch of people in the researchers in the CS community, like Fei Li and some of these people that have done a lot of data-driven pedestrian modeling. Their objective is simply just looking at it as an application, not necessarily as an application of their tools, not necessarily for a very particular purpose. That's at least my understanding of those papers. So how do you see the role of such models in traffic flow?
Every model that models the movement of a person or bicycle correctly is welcome. Okay. At first, but I think I'm still in favor of physical models. I'm an engineer, and the big advantage of a physical model is that it is understandable and reproducible. From a methodological point of view, and we have 1 or 2 papers on that, physics-informed neural networks could be an interesting modeling approach because they can combine the strength of a physical model and of an AI approach. And I think not too many people use them up to now, and it might be difficult. Also, this field might need a little bit more development or better or easier to use modeling suites or whatever. But this could be interesting, but at the moment I'm still in favor of physical models.
Do you see any room for hybrid models? Like sort of, I think that physics-based neural networks are sort of hybrid models. So.
Yeah, I mean, I did my PhD on AI, or using an AI approach for ramp metering. It has lots of advantages. Yeah. One is also you could use it for calibration and validation of existing models and so on, or for fine-tuning things. But the understandability of a model, and that's my background, I'm coming from practice, and I think things are accepted in a market and at the customer when the customer understands things a bit. And that's hard as soon as you use AI.
Yeah, that's the whole idea of understandable models that you can explain is becoming more and more important because it's becoming easier and easier to make these AI models more and more complex. It's less expensive computationally to do it. So, but yeah, so this goes back to the very first discussion we had in terms of the role of industry and academia, and like typically in academia I don't want to generalize this, but I feel like there's this push towards innovation without the need to, if this is really a useful thing and I get it for like some fields like physics or math, this might be true, but for engineering, I always felt like that connection is useful to what really is needed. So that the ability to explain the model to more so that you can assess it is important in some sense, right? So how your experience in this, you've been in contact with industry all your career. How do you see industry seeing this now that AI and data-driven models are becoming widespread?
I think there are fields where it absolutely makes sense. Image recognition and things like this, where AI-driven models or based models are very, very good, very fast, reliable. And nobody really cares how this little box was detected in a picture. Right. But we are modeling humans. We too know how a human works or thinks, or we think we know how a human thinks. And I think, therefore, it's always good to model things that you understand the behavior. So not having a black box that does something. So you could say, okay, this person evaluates travel time, and based on travel time, it makes a decision. And I think this could get lost when you bring in AI, and that you fully rely on an AI-driven model. We are doing some research with explainable AI, so especially in the area of mode choice. But still, it might be hard to convince a person that worked many years with logit models and so on to now switch to an AI approach. And in industry, I think it's pretty much the same. There are fields where AI is established and absolutely makes sense, but others where they still go into the direction of classical, let's call it conventional modeling. And I absolutely share your opinion that in our field, I sometimes have the impression people are not evaluating a priori what method they use. They just publish a paper because they want to be the first that ever used a specific method or model for a specific problem, if it makes sense or not.
That's the whole idea behind like engineering research, because for me it's still there's not a very clear boundary of, okay, where does this become pure research with no application, where it really should focus on application. So it's always been hard for me. So I really enjoy your view of data. What you're essentially saying, if I want to summarize it, correct me if I'm wrong, you're saying that's not why we collect data. We collect data because we want to have a better understanding of how the humans behave and what are the dynamics, rather than just targeting a specific types of model. Right? Do you agree with that assessment?
Absolutely.
Okay, that's very nice. So you've gone through a lot of trouble to collect a very diverse set of data, right? So I want to get your opinion on, if someone wants to start collecting a specific type of data, let's say drone data, what are the challenges? What are the areas you think that we don't have enough data for? And what are the areas that you think it's a waste of time to collect more data because you already have enough?
I think for freeways we have enough data. That's so I would definitely go into cities in an urban environment. And I think we still not have enough data at places where we have lots of vehicles, pedestrians and cyclists simultaneously. And a big challenge is the regulation or authorities to get a permit to do drone experiments. Also the organization of a drone experiment is very time consuming. You need lots of drones, you need drone pilots with specific licenses. And you need to be lucky that the weather is good and no wind and that the traffic situation that you want to monitor or measure is really happening on that day, on this specific day. And what I see is later the image processing is not that big of a problem. It needs, in our cases, we tried out several companies, it still needs lots of manual work, even after fully automated processing all the videos. But definitely I would go into big cities, Arc de Triomphe in Paris, or big icons of the transportation model, or the transportation system we should have data sets for.
Yeah, so one thing I always thought about that, well, actually, I don't know this. I always thought that geometry would have a huge impact on traffic flow. I don't think it has been investigated extensively. So when you pick a location, how do you decide this is the right location for this data collection?
I absolutely agree that geometry has a big influence, in my opinion, as well. It depends on many factors. Yeah, we always wanted to have a broad variety of modes there. And when you use a drone, you also need a location where there are not too many trees, where everything is observable from with the video camera. So there's so many constraints that at the end there are just a few over, and then you decide on one. Yeah? And in our case, we mainly looked: is there a major arterial? Is there a bus running? How many pedestrians and cyclists are there? And then we choose the location.
So have you done any sort of data collection, like repeated data collection in a particular location to see how it's changing over time?
The drone experiments were on 2 days, and we compared the 2 days, but we have not repeated it afterward.
Do you see any value in repeating this, or do you see value in more expanding our location? I'm trying to establish some sort of, if there is any sort of mechanism that the research community can come together and say, okay, well, here's what we have collected so far, and here's what we can learn by these, and here's what we don't know about. So if someone wants to go collect drone data, here's what is missing. Why don't you focus on those? Because the rest we covered. Is there anything like that? Do you think anything like that can ever happen?
Yeah, I don't see an entity or a person that is really providing this overview at the moment. And every researcher that is doing their own experiments or floating car experiments is looking for data sets and then says, okay, I have this one and this one. And most of the researchers say, the thing I'm missing or I want to do is missing. So I have to conduct my own experiment. Yeah. And that was pretty much the same in our case. Yeah, I want the German driver mentality. And that's also something that probably is not investigated enough. Different countries, different driving styles. And we as German researchers are interested in developing solutions for our system. Of course, they should be transferable and so on. But I doubt that an experiment from Greek or from Michigan is really transferable to the situation here in Munich.
And that's sort of a well-established thing for other things like demand, like travel behavior. But I know in traffic flow, we always talked about it, but we used to just have NGSIM. So everyone was using just NGSIM. So, and
but for example, there's a speed limit there in Germany. Parts of the freeways don't have speed limits. The fleet in Germany is totally different. We have lots of cars, BMWs, Audis, Mercedeses, with more horsepower. But in the US, you have huge cars. Yeah, And I think this has more impact on the system and influence that we think. Because I feel a difference when I drive on an US freeway compared to a German freeway. And in a way, that's traffic flow.
Okay. So when you're doing these experiments in your test track, are there any sort of considerations in terms of this is whatever you're doing is considering like sort of a German sort of behavior, like pedestrians behave this way. So do you think those are transferable because they are feel like they're like controlled experiments, or do you still have that factor of the like cultural effect, let's call it?
Since it's controlled, you could, of course, tell the participants what to do. German pedestrians follow the rules, so they really stop at red signals. I hope you saw this on your way to the university here. So that's a big difference to many other countries. And when we do a German experiment, I would definitely tell the participants of the experiment to behave like this. When I say, okay, do it the American way or US style, then I would say some people do not care, look left, look right, and when nothing's coming, cross independent of the red signal. So you could imitate that in an experiment, and by doing this, create data sets that could be used worldwide.
Interesting. Well, okay. So in Chicago, people follow the rules while it is not too cold.
Okay.
When it gets too cold.
That's a very specific command we then have to give to the participants.
You don't want to wait like in negative 30 degrees when there's no one on the road. But okay, no, I'm not advocating for crossing red lights. So this is interesting. So there's one more thing that caught my attention in your studies, and that is the whole idea of lane-free traffic. Mm-hmm. So that caught my attention. Before reading your papers, I remember I used to see like some sort of lane-free traffic modeling coming from India or some like Southeast Asia, but yours is a different concept.
Mm-hmm. The idea of lane-free traffic is from Marcos Papageorgiou, who is a TUM ambassador also, so there's a close relation also to my chair. And what you describe in India or Pakistan, we call it lane-less traffic. So very different or heterogeneous fleet and vehicles all over, more or less, but very uncontrolled, very unsafe usually. The vision of lane-free traffic is full automation, so 100% automated vehicles and full control over all vehicles. And in a way, that's a very advanced and far away approach. We won't see this the next 20 to 50 years. But together with Marcos, we did some really, really interesting simulations. And we see, for example, under the vision of lane-free traffic, so we get rid of the lanes, this fully automated, very efficient vehicles could use the complete infrastructure. We see capacities much higher than today. And this is very interesting because there's still lots of people telling us to invest in additional lanes. And when we see such fantastic results or interesting results, and I'm very convinced that we could see smaller gains in capacity even with lower penetration rates, we should motivate politicians or people from the infrastructure industry to invest money into automation instead of adding new lanes to freeways. Because that's just a waste of money and of resources and produces lots of emissions. We could say by creating a much more efficient system based on lane-free traffic, on optimal algorithms for automated vehicles, we can still increase the capacity. It's not necessary to add a lane. You could even reduce a lane. Then this is very, very interesting and could help us to operate the future freeway system better, but on the existing infrastructure without any further additions.
So the idea is to centrally control them, or have a set of rules for each one of them to operate independently.
Both could be done. Centrally is, of course, very efficient, but it could also be done decentralized. And we have a very interesting paper called, the idea is called internal boundary control. So a freeway with two directions. You could give space accordingly to the demand. In transportation, it's usually lots of traffic in the morning towards the city, in the evening outside of the city. But both directions usually have 4 or 5 lanes of a freeway. And in the morning it's congested inbound, evening outbound. And by allocating the space dynamically, so to shift the internal boundary just a bit and give one freeway a bit more space for the morning and the opposite in the evening, you could also significantly improve the freeway operation. You see that on bridges, with tidal flow systems, where a lane is dedicated in one direction in the morning, evening other direction. I think the Golden Gate Bridge is something like that.
Yeah, I think I've seen one in Philly that they do that, but that is a very complex process and it requires a lot of safety precautions. But I think with central control, it can be done within seconds.
Yeah, I mean, what I'm talking about is very futuristic and is the final stage of automation. But I'm very convinced that even with smaller penetration rates, 10 to 15, 20%, we could already achieve some capacity gains. And we've also developed and won a very nice prize last year at TRB, a concept of flocking. So not only platooning, but flocking, and to create an entire flock of vehicles could save emissions and save fuel consumption, because you could create a flock in an optimal way, dependent on the wind and the infrastructure. Such small flocks could be a starting point, for example, that you bundle automated vehicles together in a flock. Of course, this flock has then an influence on the remaining traffic, but by doing this, you could optimize traffic flow on a freeway.
Do you think if you designed them in a decentralized way, you would see some sort of a self-organized patterns that you see for pedestrians, or the cars would? I'm just curious, reading this would be like, depending on the rules that you're utilizing, it can just go all the way to just following sort of non-existent lanes. They can just form a lane themselves, or they can create a flock. And so your assessment is the lane essentially is not the most efficient way of operating. Mm-hmm. There are better ways, which we're missing on the opportunity to operate that way.
Yeah, out of safety reasons, more or less, we waste some infrastructure. Yeah. In Germany, the lane width on a freeway is about 3.75 meters. A vehicle is roughly 2 meters. So 1.75 meters are lost. In a way, that's very inefficient.
Yeah, and yet I have a hard time keeping the vehicle in the lane. So
Yeah, you're driving so fast.
I also want to talk a little bit about education at TUM and in general in Germany, because it's fundamentally different from how like U.S. institutions operate. And I'm just wondering if you could, so this whole podcast, one of the target audience for it is the students that are trying to see, okay, if I want to do a PhD in traffic flow, is TUM the right place for me, or I prefer like a US sort of process like for education. And many people like myself, when I was applying, I had no idea how the operation works in Germany, for instance. I'm just wondering if you could spend a few minutes like discuss what is the life of a PhD student here? How does that work?
Yeah, at first, TUM is a really, really good place. I think we just got the number 26 worldwide, and it's the number 1 university in the European Union. So from this point, it's a fantastic place, I think, for a student to come. In Germany, a PhD student usually gets a position as a researcher at the chair. So we have about 40 students here at this chair, and each person has a contract with the university and is paid as a researcher. So they really get money, and I think it's a decent amount of money for their daily life. And they work on a research project, and in most cases, the research project is in line with the PhD topic of the person. So I have a project on lane-free traffic. We have a researcher / PhD student that works for this project, and also the topic of his PhD is in this direction. PhD students here have to teach because the university is public. So for Europeans, TUM is for free, which is fantastic. Yeah, we have about over 50,000 students here, so that's a lot. It's a mass university, so lots of people. And PhD students need to help. Yeah? Bachelor theses, master theses, and doing the exercises in the traffic flow theory class, for example. This leads to a situation that most students need 4 years plus to complete a PhD, because they have the project they have to work on, they need to help teaching, and advanced PhD students also need to help in acquiring new projects. So I would say you learn a lot compared to other countries while you are a PhD student in Germany. In most other countries, you often only learn how to research, how to solve this specific problem. Here you can find out if you like teaching, which is a major part of your life when you stay in academia as a professor, and you learn how to write a research proposal and to promote an idea, which is also a major part of your life as an academician. So the education includes more than purely working on the PhD topic. And it takes longer, but you are paid. But I consider the system very good because of this very broad education that you get. You need to take some additional courses, as in many other countries. There's a graduate school. And I think Tum and all my colleagues, like Konstantinos Antonio, Rolf Möckel, we are all very well connected to the international research community. Of course, students go to international conferences and publish in the same conferences than all our colleagues.
Interesting. So one thing I've noticed in civil engineering programs in US and maybe some of the European universities, there's a lot of movement towards like sort of data science, AI courses. And so is the same thing happening here?
I just started an AI course yesterday.
Okay. So how do you see the future of civil engineering education?
I see it a bit problematic, I have to say. And at TUM, we have a special program, a Transportation Systems Master Program, which is very international. And I'm teaching civil engineering students, environmental engineering students, and students from this Master for Transportation Systems. The PhD students I have, at least 50% or more have a totally different background. Computer science, physics, math. So what I see is that my research is done with people that have a complete different background. They know AI, they've learned this in a whole program. And the civil engineering student often does not have enough programming skills, I would say, and mathematical skills these days to really compete later in the international research market. That might sound a bit hard, and I really appreciate the mixture here because people from computer science or math and so they don't have a clue about transportation at the beginning and planning and all these things. And it's a really nice mixture at the chair. But when you as a civil engineer want to go into academia in traffic control or traffic flow theory, you need to be mathematically strong and you have to have good programming skills. And on average, I don't see this at the moment in civil engineering programs.
Interesting. Yeah, I kind of agree with you. One thing is also, I'm not sure I have a both positive and negative feeling about it, is the whole idea of ChatGPT and similar things. Because a lot of the students don't really program anymore. They're more of just trying to explain the problem. So, but I think that lack of mathematics background is still there. So, if someone wants to do like some sophisticated modeling that has a lot of value, that is hard.
I think this might help them to hide it a bit. Yeah, this lack of mathematical background and programming skills. But sooner or later, a person is going to find out that ChatGPT did the whole thing.
Right, that is true. So do you have like a sort of a policy about using ChatGPT in a school? Like, does the school have a policy about it?
TUM is currently working on a general policy on ChatGPT. We recommend the students to use it.
Okay,
yeah.
That's
but to be honest and telling where they used it for. And we tell them when we find out that they used it, but they didn't tell us, then they fail. Yeah,
okay, that's a good approach. That's a good approach.
Yeah.
I think I don't really know UIUC's stand on it. So I know we cannot purchase any services through university funding. That is prohibited. So, but I don't know what is the policy for using it. I let them using a class, but I don't know. I don't think there's a general policy. It helps to have a general policy. So then in that case, if someone violates it, you know how to deal with it.
I mean, it's a fantastic tool, and I see the problem for master and PhD theses, because I cannot really tell did the person program it by herself or himself, and it might lead to a situation where we do more oral exams in the future, or coming back to the PhD, the oral final exam might be more important than today, and where we look at the written thesis or the papers that the person produced. It might be interesting to see the person when we ask questions without
The
ChatGPT.
That is a good approach. I've never thought about it that way, but that's a very interesting approach. Not research related, at the same time research related. You are going to have 2 big conferences next 2 years here. Mm-hmm. So I thought that this might be a good opportunity to talk about them.
Oh, yeah. Advertisement. We're very proud and honored that we will host HEART. This is a European conference. Advanced, experienced PhD students usually present their work there. It's a yearly conference, and very interesting. You meet lots of European colleagues, but also international colleagues that come. And the call for abstracts is already open. It's only an extended abstract, that's all, so no publication, but very nice and interesting environment. I think usually 4 to 5 parallel streams. And it's very good for networking in Europe. And the quality is really high, I have to say. I've attended the last 3 HEART conferences. We usually send students there as well, but the students should already have something, not presenting an idea, but presenting already some results. And we are very proud to host ISTTT 26 in 26. It's the second time ever that this very prestigious conference, the International Symposium and Traffic and Transportation Theory, is in Germany. It was in the late 60s in Karlsruhe with Professor Leutzbach, and now it's returning to Germany, and the first time ever to Munich. Also for this conference, very prestigious conference with journal publications at the end, and 2 rounds of comprehensive reviews started. The call for abstract started. I think from next week on, the portal for uploading the abstracts is available. Konstantinos Antonio and I are organizing the whole thing. Both conferences are organized by the 2 chairs. This means lots of work. And hopefully we can demonstrate the German organizational skills here to our colleagues. And we found already 2 very nice spots where we will host the 2 conferences.
On behalf of the entire community, if I may, I want to thank you for that. I know it's a lot of work. It's fantastic. Thank you so much for taking time. It was a really nice conversation. I really enjoyed it. I hope you enjoyed it too.
Absolutely. Yeah, it was wonderful.
Yeah, thank you.
Thanks for coming over. Thanks for visiting TUM and Bavaria. And now I will invite you to a very typical Bavarian style lunch.
Thank you. Thank you so much. Thanks for your time again. Thank you.